Welcome to another video of Grokking the Coding interview series where we are going through the breadth first search approach for the trees. And in this video, we'll have a look at ZigZag traversal problem, which is classified as medium. Uh, so in the previous video, we went through the level or the traversal where we printed out the nodes at each level of the tree. Further on, we had a look at the reverse level order traversal, which was again an easy problem where we simply had to print the elements from right to left instead of and bottom to up instead of going top to bottom and left to right. And in this case, in the zigzag traversal, we simply have to print the elements in the following order. So if we start at the root node, we after the root node we have to go from 3 2 and then from 4 5 6 7. So you see we go through the tree in a zigzag manner. So let's go through the problem statement and see how we can go about implementing it. Given a binary tree, populate an array to represent a zigzag level order traversal. You should populate the values of all nodes of the first level from left to right and then right to left for the next level and keep alternating in the same manner for the following levels. So essentially, the only difference and in from the previous implementations and in this implementation will be when we go ahead and um, create an array or create a queue with all the elements of the current level. There we have to choose if we want to append from the left side or the right side, and that would specify um, our zigzag traversal like approach. So let's just have a look at a few examples. Here we already saw, we'll go like this. Here it'll be more like this, and it all makes sense. So let's go ahead and try to implement this problem. And the way I'm thinking of approaching it is we want to maintain an alternating flag where we know if we want to compose the result for the current array from left to right or right to left. And I mean, of course, the default order is left to right. So our flag will be true to start off with. So let's go ahead and try to implement this solution and see how that would work. So again, the same standard exercise. If root is none, we return the result. There is no traversal. We need a queue. We want to import it from collections. Collections import queue. We initialize the queue. We push the root, or it's actually the queue, if I'm not wrong. So I have to cross check if my spelling of DQ is right, but we'll encounter it as we move forward. We'll push the root. The outer loop will be pretty standard while Q isn't empty. We will keep iterating. Let me create more real estate for us to implement this solution here. So what are the things we want to keep a track of? First, I want to keep initialize that alternating flag, which we will need. So left to right, let's initiate it to true. So from first level or from 0th level, we want to start printing the elements from left to right. And then we'll keep alternating and print it from right to left and move on in that direction. So we want to, as again the standard exercise, length of the cube will be the number of nodes we want to push out at this level. We also want level nodes. This will be a queue Again, for the same reason that we want to have the flexibility of either appending to the left or the right of this queue, and then we iterate for level size amount of elements. Our current node will simply be queue.pop left. Okay, now is where we want to change things. So if left to right, then we go ahead and simply append things the usual way. Level nodes dot append current node dot val else level nodes dot append append left and we have to go ahead and push the left and the right subtrees of this node into the queue. So if current node dot left queue dot append current node dot left, if current node dot right, then we go queue dot append current node dot right. And at this point, once we have gone through this level, we want to switch the flag. So left to right will simply be a negation of what it is at the moment. And this way we can switch this order of how we append into how we append the nodes into the level nodes queue, and this would provide us with that alternating traversal which we are looking for, or zigzag traversal to be more specific. Okay, so let's go through it again and see if we have the right implementation. If the root is empty, return result. Initialize a queue, append root into the queue. Left to right flag is true, while queue is not empty. We have the number of nodes we want to pop on that specific level. We have the nodes from that specific level. We are specifying a queue here. The reason we want to have the append left flexibility for range level size, we extract the current node. If the flag is left to right, we append the node to the end of the queue. Otherwise, we append it to the left of the queue. And we go ahead and do the normal operations. I still am slightly a bit confused here, but again, let's run it and see if it leads to what we're expecting. Uh, One thing which we forgot is actually ending the result into the results. So because it's a queue, we have we will cast it into a list. So it will be level nodes here. And this should give us what we are looking for. Okay, so let's see if we have the answer which we are looking for at this moment. We have 12, 1, 7, 9, 10, 5, and 17, 20. Okay, so seems like our zigzag traversal approach is working. The main pointers here are the use of flag, of how you go about alternating the way you push the nodes into your result queue. And that would be it. I hope you found the explanation clear. Let's quickly speak about the space and time complexity of this approach. we are only traversing all the nodes once, so the runtime will of course be O of n, as we have seen in all the previous implementations. When it comes to the space complexity, again, we are using a queue, and at most that queue can have n by 2 elements in it. Um, and we also have a result array which will contain all the elements of the tree. So at max, it's simply O of n, and that would be it. Like, I hope you found the explanation clear. Please let me know in case something was not clear, or if you want me to improve in any other direction. Until the next video, have a great day.